All right, 1:15, folks. I had to reschedule today's session, so I'm gonna go through some stuff for a while this morning, and then this evening I'll be on also. So if there's questions that come up, then you have fifth online homework that's wrapping up, and the lab with just a whole bunch of factoring exercises that I've gotten some questions on that. Some are working on that, so questions on any of those, and we're going to look at different place where factoring actually helps us to solve something that's kind of wraps up this chapter. I didn't want to do it too soon, but I'm going to spend some time on solving equations by factoring. Now, how the factored form helps us actually get solution to an equation. We haven't put it in that context yet, so we're going to look at some of those while I'm on today. Let me get this positioned. This is this one that I sent the announcement about on the lab where the answer key was wrong. So I have that written up here. We'll get this situated. We had, this was number 15 in the lab. I think was the right number for it. And what they have in the answer key, if you multiply it out, it comes out to this thing, but it's not completely factored because they pulled out a common factor, but they didn't pull out the greatest common factor on that. So 24xy is what should have been factored out, and then it's easy factoring from there, but this is the complete answer. When you have a GCF like this that comes out front, then you look and you can factor this thing further, which is typical here. You write the factors down in your GCF is just here. That's one of the factors on it, or part of the factored form. So the whole thing is written out there. That's where that should look in the end. All right, so I want to look at some more factoring, but I'm going to go ahead and put it into a different context. So let me kind of introduce this idea. We're going to use factoring to actually solve for something. Now, so far, we've just had problems where we are finding the factored form. It just says factor the thing. We didn't think about particular values of x or y in any of this because we're just writing it in a different form. But there is a place where this helps us solve an equation. So I want to think about think about solving equations again, which we do in all kinds of settings, but now we're going to do it involving things that need factoring, solving equations by factoring. So it's a key step in finding a solution to a particular kind of equation, and really any polynomial equation, this is going to be part of the deal. So if you have exponents in there, you probably can't just get x by itself by shuffling things around. But if I have and just write down an example of a polynomial one. 48. I have a polynomial thing like that, and I want to see where that's equal to 0, or 3x squared minus 5x is equal to 28. That's another form of the same equation. I just moved the 28 around. Those both mean the same thing. And it's not obvious from looking at that what value of x would work, right? And I can move terms around, but I have an x squared term and an x term. They don't combine because of the exponent, and I can't isolate just x when there's both of those things going around. So multiplying and adding stuff to both sides and dividing by stuff, I'm just not going to be able to get this in x equals form. It doesn't work that way. I have to do something different to make that possible. And we're going to use a different property that will help us out in that situation. Let me get more light on this. We're going to look at something called a zero factor. Might help. So I want you to notice something about factors. If I have the number 12, we've been looking at things that multiply to a number, or factors of a number. So that's Lots of ways to multiply to 12. You could be 3 times 4, or you could be negative 6 times negative 2, or you could be, actually, if I allow decimals, I could have even more different kinds of things, or fractions in there. I could have a lot of different ways of doing that. We could have 7/5 times 60 over 7 would come out to 12. There's lots of ways of multiplying to 12, and that's not very helpful. Even a simple thing like 1, it could be 1 times 1, or it could be negative 1 times negative 1, or it could be 3 over 7 times 7 over 3, or I could keep going like this, but the fact is that doesn't tell us what either of the numbers are. But there's a very particular thing that happens with 0, that multiplying to get 0, this could be 5 times 0, or it could be 0 times negative 11, or it could be 0 times 165, or 15 times 0. But the point is, there has to be a 0 in there. The only way you can get an answer of 0 for multiplication problems is if one of the factors, one of the numbers that you're multiplying, is itself 0. And that doesn't happen with any of these other numbers. These don't have to be 1, these don't have to be 12, nothing has to equal the number, except in this particular case. That's a property, arithmetic property, that's going to be very useful to us here. It's called the zero factor property, which is a great name for it because it kind of guides us through applying this in these polynomial equations that we're looking at. The zero factor property is going to help us an awful lot. But it says if we know that something times something comes out to 0, then we know that either A equals 0 or B equals 0. That's the property written out. It's just the way multiplication works. We're going to make that very useful when we're solving equations. Now, the one that I wrote down just a minute ago, I'm going to come back to here. We had 3x squared minus 5x minus 28 equals 0. We want to know the value of x that'll make that come out to 0 if there is one. We like know what they are. Maybe there's more than one. We will find out that there's more than one, actually. But we're going to take a look at that now. Now, I wrote it in this form with a 0 on this side. But these are 3 things adding up to 0, or these 2 things have to add up to 28. So it's not obvious what they would be separately. But if I write this in factored form, we're going to be able to make a different kind of observation about this. So if I can factor what's over here into factors, and we're somewhat experts on factors right now, so I'm going to write these factors. And it's not obvious what the factors are either, but I can think through the factoring on this. I must have 3x and x. Open 7. So I got minus 4 and plus 7. Actually, yeah, okay, that works out. So did a little mental work there to think about what those factors would be, but those are the factors that work out. This multiplies out to negative 12x plus 7x, which is negative 5x, and then the negative 28. And so that works out as factors of that thing. But here's the observation on this property. I just wrote this in a form that says something times something equals 0. The product is equal to 0. So one of the factors has to be 0. In order for that to come out 0, either 3x plus 7 is 0, or x minus 4 is 0. It separates my equation into 2 separate equations. That's what the property does. Now I can solve for x and those things. I can get x by itself in equations like that much easier. I just got 2 nice little equations. Now notice the name of this thing, the zero factor property, is also really the steps that you have to go through. I have to get it written with a 0 in there, and then I have to factor the thing, and then the property is what splits it off. And I can solve from there. If x minus 4 is 0, then x equals 4. And if 3x plus 7 is 0, then 3x is negative 7. So x is negative 7 divided by 3. That's kind of doing normal algebra on it from there. So we turn our bigger equation into two nice little equations that we can solve out using normal steps from there, normal equation solving steps from there. That's what the zero factor property does for us. As long as we can find factors, we can separate equations into nice smaller equations. We do have two different numbers, and they both work in this thing. If x is 4, I'm going to get 48 minus 20 minus 28, which comes out to 0. And if x is negative 7/3, then these calculations would be a lot harder to do. But if you go through the steps on that, you're going to find that does come out to 0 also. But both equations are going to work. If you do your factoring right and your steps right, you are going to get solutions that both work in this thing. It's typical for something with a squared to have an x in each factor, and that means it's typical to get two different answers for it that both work. That's what that property does, is split things up. We could have more factors, usually just two factors. And that's really takes a complicated equation, makes it into simple equations. That's what factoring does for us. It's one place where factoring is really useful. Now, I want to point out that one of the problems a lot of people run into with this is that once they get used to doing this, they turn factors into solutions like this all the time. These steps are pretty natural, but this stuff only applies if you're talking about an equation and you're trying to solve for x in an equation. If you just have a factoring problem and you just have an expression written down, then you don't care about the values of x and you're not solving for anything. So you got to apply this into context, but the context is a polynomial equation, right? That's where we're using it. Let me write another one down and think this through. We'll get some factoring practice in the work here, but using it in the context of equations. So here's an equation. I'm not taking these out of the book or anything or the lab. I'm just making stuff up at this point. But here's a polynomial equation. It's got x squared term and an x term and a number term in it that I got to work through this. Form that it's written in doesn't make those solutions very obvious, right? I can't get x by itself. I could get rid of the 3 here by dividing by 3 over there. But that really doesn't get me a form that's very useful. If I still have an x on both sides, can't really have that. So I'm going to use this zero factor property on it. I'm hoping I can turn this complicated equation into simpler equations. I got to use the zero factor property. Now, the nice thing about remembering that name that I keep saying over and over again is that name is also the steps of this thing. We have to get a 0 to get started. And you can always rearrange these equations by subtracting and adding terms. So I'm going to subtract 11x from both sides, but they don't combine because of the squared. And I'm going to subtract 20 from both sides to get the 0 on this, but that's all unlike terms. So you can always rearrange the terms to get everything to one side. And that's what I mean by the 0 thing. We have to get it in this form where it equals 0, because that's the one number that has this magical property, this basic arithmetic property, really, that the only way to get 0 is when one of the things that you're multiplying is equal to 0. So now we got to write it as a multiplication problem. In other words, we got to factor now. So that's the next step, is to get this thing factored. Now, I'm using ones where the factors aren't super easy here because we're trying to still get better at our factoring deal. And usually at this point, you got to stop and think through the factoring, however you do factoring. I'm going to write this one out. off to the side here so I know what my factors are. I don't have a GCF to pull out because there's nothing that goes into all of these terms. So I'm factoring it like usual 3-term factoring problem. I have to think about the numbers in here. What numbers are going to multiply to negative 60, but also add up to negative 11? 12 and 5 don't work, 10 and 6 don't work. I'm going to have to have let's see number one. It's not 1 times negative 60. It's not 2 times negative 30. It's not 3 times negative 10. They do have to have opposite signs on this. What did I do to myself here? 15. Oh, 3 times negative 20. Just keep going here. That should be 3 times negative 20. 4 times negative 15 is actually what I'm looking for on this. That adds up to negative 11. So that's 4x minus 15x. It's my hope that going through the lab and the work that went along with it this week, that you've gotten fairly good at this process. We're going to keep putting it to use here. Common factor here is negative 5. Really, this is x minus 5, and this is 3x. 4 that I have in common, so those are my factors. Now, property. So I got the 0, I got the factors, I'm going to use the property now that says the only way these could multiply to 0 is if either x minus 5 is 0 or 3x plus 4 is 0. So solve those things out and you get your 2 answers. Fractional answers come from factors like that. Nicer integer answers come from simpler factors like that. But we get 2 different answers to these things. If we started out with a squared, we're probably going to get 2 solutions to the thing. There's exceptions to that, but those answers will both work. Those are the 2 solutions to that equation. If I plug those into the original, I should get what I'm supposed to get here. This should come out the same on both sides. If I do the check carefully here, I got to deal with 3 times negative 4/3 squared. The original equation, that's supposed to equal 11 times x plus 20. So I substituted in the x value here. Work out what that is. 3 times 16 over 9 equals 11 times negative 4/3 plus 20. I have to think about multiplying fractions here a little bit. But I got a common factor of 3 I can take out. That's going to be 16 over 3. This is going to be negative 44 over 3. And then on the plus 20, I'm going to go ahead and get a common denominator there. So you can see those do add up to a positive 16 over 3. It came out the same on both sides. It does work as a solution then. And with the 0 factor property, they both have to work. I mean, if you do the steps right, those should be fine. Because if that's the number that makes this equal to 0, then of course this product is going to be 0. The original equation is going to come out true. So nothing magical there. I mean, this, if you do it right, your answers should always be solutions of the original equation. If you happen to drop in on the middle of this, certainly willing to take some questions on this if you're stuck on anything from the homework or the labs. We're going to have, just while I'm thinking about it, I think we have, see, I'm coming up at the end of next week. So looking back at the schedule that I put up in my earlier announcement here, we're on what I called week 2, which is the regular factoring, including 2, 3, and 4-term factoring. We're going to start the rational expressions, and then we're going to take a test on it. So I tried to keep the tests about the days where the tests were usually scheduled anyway. And that comes up next week, even though we're not going to finish all of Chapter 6. We're going to do part of Chapter 6 next week and then take this test. So what I'm going to put out Monday is regular links with the work going on and some times when you might take the test. I'm going to give you a few different times toward the end of next week that are available test times, and you're going to tell me which one of those times is good for you. Hopefully one of them will work. Let me know when that is a good time for you to sit down and work on the test, because those do have kind of a time limit thing. I will send the test at the beginning of the session, and you're going to do the work and return the pictures of it into me at the end of the time slots. I'm going to make them like 3-hour long time slots, so you have plenty of time to do it. But it is kind of on a strict time limit there. So because it's a test, they're open book tests now, but you got a certain amount of time to work them, and you can let me know what time will work for you. So I will have the particulars of that out in Monday's announcement. And you want to get back to me soon after that with which time slot works for you. Split it up that way. The other thing I want to get a lead into is a little bit more on rational expressions. So I want to think a little bit about how multiplying fractions work. We just did some fraction multiplication in the context of this last problem here. 11 times -4/3 and 3 times 16/9. I want to think a little bit about how fraction operations work, because that's where we're headed next, is we're going to look at the algebraic version of fractions. What if we have a numerator and denominator with variables and polynomials in it even? We're going to work those kind of multiplication problems. But I want to think first about how the process works here. For simple fractions, if I have something like 5/7 times 11/2. So going back to the arithmetic ideas of this thing, when you multiply fractions, you just multiply the tops and bottoms. So you can think about this. You just get 55/14. Right? That's one of the easier operations to do with fractions. You're just multiplying the top and you're multiplying the bottom. You can think of this as numerators and denominators. Essentially, we're just making one big fraction of it, and we're doing the multiplications here. I just kind of draw a line across there and multiply these things that are on top and these things that are on the bottom. I threw the parentheses around this because that's how we're going to see it now if I have expressions like this involved. X over x minus 5 times 3 over 4x. We can multiply those, and we're just going to multiply the top and we're going to multiply the bottom, but we have multiple terms here. So we got to think a little bit about distributing in this one because of the terms that are there. This is just x times 3. So I can throw these in just to see what's going on, but you're just doing this multiplication. X times 3 is 3x. X minus 5 times 4x is 4x squared minus 20x. And that's how multiplication works. Now, when you get an answer in a fraction problem, you should look at it and see if it can be simplified. Right, 55/14. If there was a number that came out of both of those as a factor, I should simplify it out. I should divide that out, right? But 55 and 14 don't have any common factors. There's nothing I can take out to write that in a simpler form. If I look back over here, I can see what all the factors are, and there aren't anything in common. It's going to simplify out. This one does have an x that's in common here and here that I could divide out. Or cancel if I write it this way. This is 3 times x, and this has a factor of x in it also because there's an x on every term. So I can cancel those things and write that in simpler form. I want to write it in that simpler form if possible, so I want to catch those factors. Now, if you're thinking, I could have saved myself quite a bit of trouble on that if I'd noticed it earlier. You're definitely right about that. The original problem here had these things separated out, and I could have noticed right away that this had an x on the top and an x on the bottom. And we're thinking about factors there, but that's times x. That's x as a factor to that. I could have canceled them right from the start, and then I would have gotten 3 over 4x minus 20 without having to mix that up. So writing everything in factored form to begin with helps us with that. And we got to think about what the factors are so we can make sure we write that answer in simplest form. So if I have x squared minus 4 over 5x, and I want to multiply that by x plus 3 over x minus 2. These are the kind of expressions we're doing in the next chapter. So I'm leading into that a little bit. This is what chapter 6, I think it's chapter 6 is all about. So multiplication is really just putting together the stuff that's on the top and putting together the stuff that's on the bottom, but we do have to look for these common factors. So the first thing to do, throw these containers in, and I want to think about factored form right here. Now, when there's a squared, I got to see if that can be factored a little bit more, and it can here. X squared minus 4 factors. That is one of our difference of squares factors, so that can be factored that way. Copying the rest of this down. But that's really the hard work on this, because multiplication just means this. Put them together and get rid of any common factors. Notice the x minus 2 here is a factor of the top and bottom. So I can divide that out just by crossing it off. There we go. The answer is x plus 2, x plus 3 over 5x. Nothing else in common right there. Now, if you want to go ahead and multiply that out, you can. There's a couple different ways to write this answer, because this is the same thing as if you actually FOIL this out or multiply it out. You get x squared plus 5x plus 6. So it could be written that way. Notice they both have a 5x in them, but I don't really care about common terms like that. That doesn't really help me at all. The fact that there's a 5x added in there, the only thing that helps me simplify it is common factors, and the 5x is not a factor. The factors were all different. So I really like this form better, but if you multiply things out, that's okay. It's a little bit like having the number 250 or 157 over 5. They both have a 5 in them, but that doesn't really mean anything because they're not both divisible by 5. I can't simplify that. I can't cross off those 5s there and get 107 or anything like that. That just doesn't simplify because there's no factors that are the same in those things. So the factored form is the useful one, and we're going to deal with everything in factored form. So it's another good use of factoring. We're going to continue to get a ton of practice on factoring problems as we go on. That's two different contexts where the factors have helped us a lot in equations and in these expressions where we have fractions, or we call rational expressions. So that's places polynomials can show up. They can show up in an equation, and the zero factor property is useful, and they can show up in a fractional expression like this. That's what we're going to be dealing with next. The basic questions on fractions are going to be on the test next week, at the end of next week, and we're going to do a little bit more complicated stuff with them on the following week. So we're going to be spending a lot of time on these kinds of rational expressions. And getting stuff written into factored form is really the key beginning step to everything we do with rational expressions. So if you're an expert at factoring now, you're going to find this much easier. And if not, you're going to continue to get plenty of opportunities to practice your factoring skills, because that's still what we're doing. That's still what we're spending a lot of time on, is finding factors. So let me work with kind of an ugly one here where we get a little more factoring practice. I don't want to go on and on here too much, but I'm going to take one out of the book that does this multiplication process and involves a bunch of factoring. All the different factoring techniques that we've used can all show up in here. So I'm going to grab one out of that chapter and I'll copy it down here so we can see what we're working with. Another multiplication problems. And
well, you know what I mean. It's a dust dog.
It's actually chapter 7 in the textbook. I think I gave the wrong chapter number. But in our textbook chapters, it's chapter 7. 7.1 really is where these are coming from. I'm going to grab one of the exercises out of the textbook here.
Okay.
Opportunities to apply some factoring on different forms. So I'm going to take one of the ones that has more involved factoring in it. We're pretty far into this section. This looks like here. It's actually number 46 from this chapter. Oh no, that's a division problem. That's not what I'm going to do. I'm not going to get into division right now. I just want to concentrate on multiplying. So number 39. Multiply problem, and we got this big fractional expression. C squared minus 10c plus 25 over c squared minus 25. That whole big fraction multiplied by c squared plus 10c plus 25. 3c squared minus 14c minus 5. So this is actually one of the big longer multiplication problems I'll look at. And I just want to multiply the tops and bottoms, but I don't want to do it now. I'd get great big long things and I'd have a terribly hard time finding any common factors from that. So I want to start with factored form just so I can see if it simplifies first before I put it together. So I can throw containers around these, but I actually want to split them up further and get one big fraction with the factors of all of this. Now, first thing to look at in factoring problems is whether I can pull out a GCF from the whole thing. There's nothing in common with all of those. There's nothing in common with both of those. There's nothing in common with all of those. The 3 doesn't go into the other things here. No GCFs to pull out. So we go on from there and think about the different kinds of factoring. I have 3-term factoring and I have 2-term factoring. 2-term factoring has to fit one of our special forms. It's got that 0 middle term, if you will. That has to be factored. It's a difference of squares. 25 is 5 squared. So I'm going to think about some of the factoring off to the side here. I can write that as c squared minus 5 squared. So the factors end up c minus 5 and c plus 5. That's going to show up a lot. Those difference of squares show up in a lot of the exercises from this, so get used to seeing that. Now, the other ones are regular 3-term factoring. I'm going to kind of write down the easier ones from here, and I'm going to spend a little more time on this. With the 3 out here, it's a little more interesting factoring. This just factors into c minus 5 and c minus 5. That adds up to minus, and that works out. This one is all plus, so the factors are all plus. And again, 5 and 5 are your nice numbers there. This one has the 3 on front. It's a little more complicated. Let me work this off to the side. I would have to think about numbers that multiply to negative 15, but add up to negative 14. So those numbers are positive 1 and negative 15. So these terms are 1c and minus 15c. Those are the numbers inside the factor. I still need to do inside out stuff to get the numbers on the outside of the box that are in my actual factors. 3c and 1. Here's a case where these two things don't have anything in common. The GCF is 1. Here they have a c in common. And here the minus is in this row. So this is a minus 5 common factor there. So I got factors 3c plus 1 and c minus 5. Now that everything's factored out completely, I can do the simplifying before I put it together. And it's really just playing a matching game here, except all the cards are face up. Now, I know exactly what I've got for all of them. You're just getting rid of pairs. As long as the same factor is on the top and bottom, it doesn't matter which side it's on because they're all getting put together. So the same thing on the top and bottom will always cancel out. These two I can cancel because they're the same on the top and bottom. A lot of that simplified out, and I get a very simple looking answer. Just came out to c plus 5 over 3c plus 1. So that's the simplified form of the answer to that. That's how multiplication works though. All right, looks like we don't have a lot of people chiming in during this time. I want to leave this up for people to watch later if you get on later. So if you were hoping for an afternoon live stream, I'm not able to do one of those today. I put out the announcement that it's rescheduled. I will be on this evening, but you can watch this and hopefully benefit from those examples. That's the end of factoring stuff and sort of the beginning of this rational expression stuff. I'll talk some more about these this evening. People are able to be on 7 o'clock or so. I will have another link up, another live stream, 7 p.m. tonight. And then wrap up your 5th online homework. Get that lab into me. Between now and Monday sometime, I'll have the new workout Monday. You all have a good day.